So, good morning. Hope all is well. Thank God for the new day. This morning I would like to share something on construction stage for 80-meter span steel truss bridge, Warren type with vertical members. As you can see, normally these steel trusses are very heavy, and so when the design is done and you are given an opportunity to construct, you need to be very careful and do a bit of planning. So what we need is how do you construct this bridge? You need to think of crane, you need to think of assembling them in compartments that are easier to lift and assemble. You need to prepare temporary platform in between here, because this is 80 meters, so you can actually split them into 20 meter, whereby each of the trusses can be lifted with like a crane and then put on the permanent support and also temporary. So basically this is something that I thought through. So last time when we visited a bridge in West Pokot in Kenya, I saw, and the contractor also demonstrated how they constructed. It was not just fabricating and assembling 80-meter truss, carry it here and place it. No. These abutments are all on piles, but for demonstration purposes and learning this software and appreciating the software, I just assume that this is fixed bearing on firm rock. But there are other models that you'll see with piling. So for this demonstration, I decided to keep it at this. So look at the first stage normally is for you to set out, excavate, construct substructure system. So this substructure system comprises of the foundation and abutment. So for me, the first stage you do is the construction of this. Once you are done with this, maybe 1 month or 2 months, depending on the site conditions and your readiness and capacity and capability, you should be able to do that. And once this thing is done, after 28 days is ready for loading, then you have to prepare now the platform. Temporary platform need to be prepared, and this is how you would do it. Depending on how you plan to do it, you can do the whole of this area without placing them at the position where we have about 4 panels here. We have 1 panel going to be bearing here, the next panel will be this side to here, the third panel will be here to here, and the fourth panel here. So depending on your capacity and capability, you prepare this. Now when you're preparing, make sure the foundations are firm. You don't need to take chances. We don't need to subject the truss system to deformation beyond the limits. So you prepare the footing very well. We shall see the reaction value that could guide you with the platform stability you need to do. So once you have done this platform, then you are ready now to begin assembling the truss system and carrying and putting them up. So in the third stage, you are ready to place this. For simplicity, I've already done the whole truss. Otherwise, I would have given you the truss system before the slab, and then we create another construction stage and put the slab. But for this case, or this scenario, I just considered just the whole of this to be done, and you can cast it. Then also that you can also cast. So this is how you can do this. So this is easy. You do this, you carry this truss system, assemble it, and then where this truss system are terminating, now you're going to use bolting. So all these members should be pin system. Remember the end releases, very important that you make sure where we have this, we're going to have the bolting, and in your model it is end releases, which is the pin and fix. So this end will be like fix, but this point will be pin, because we are going to do that. So construction stage number 4, I will be able to, you are able to put this truss system in place. So remember, this was still here. Now after doing that, you bring that and you assemble. And then the last one you will do is your so you're done with your truss system, and you may be taking 14 days or 7 days for every panel you construct, depending on the commitment of your staff. You are able to have a bridge erected. Now, how do you now do that? After talking, there are quite a number of things. You do the talking, you do all the bolting, talk it properly. Now, once that is done, then you will be able to release the temporary. You release the temporary support. So now your bridge is done. Now after maybe so many days, maybe 6 months or something like that, or even 1 year, depending on how fast you have done this, putting all up amenities, put the finishes, put the railing, and then you can see here when the railings are all here. Do all the approaches, so your bridge now will be ready for use. So that, then you are able to have your bridge ready, and then you can now put your these are the lane, the road lane, and then we also put the vehicles. These are the vehicles that we use, and then we do. So for the vehicle, what we could do is, I think we can trace the vehicle from I think let's see, we need to saw the vehicle moving, reading a constellation. I think I need to, when it is generated, to be able to do that. So but they are here. This is the vehicle that you apply. These are I talked about. These are the standard vehicle SB100 and other. Then now you also have what they call the combination of this loading. You have to specify all that. This being a slab, so you use this influence surface. So you come here, and basically this is the one you use, the influence surface. But if you are doing the girders and other thing, then would be the line. You do this one here. If you have done the beam surface, you use that. Then the vehicle types are all here, and then the moving load. Okay, so if you want to view if you want to see the output and other thing, we will look at. We go back to our model 1. An important thing as occurred while reaction. This one. Okay, so every time you see, this is the reaction. So every time now you can see the stress distribution. You could actually also view using the soil pressure. That's how the soil pressure will look like. You're able to see the behavior. This is the behavior when this is only the self weight. As soon as then, if we do second, because this is the reaction value I want. So for the second stage, that is what we would view, and that is the reaction value. So this truss system, you're done with the platform. They also have their value. These reactions here, is guiding you that the bearing capacity at this location should be more than these values for it not to deform, causing problem to the superstructure. But now as you begin adding the truss system, the weight also increases. You see, from 19 it has now gone to 482. That means your bearing capacity is more than this, but still this will continue as we add the other component. So now like that one comes, so it has gone to 800, 500, 479. Even the pressure here will be increasing. Then we go to our last part. Now this is 879. Now this is what you need to take note of in terms of planning the foundation here. Once you're able to plan this foundation, stability and preparation. When we were working on Kampala flyover, I think the contractor demonstrated a very good approach because it was also in situ concrete. They did very good stabilization of the foundation of the temporary support, and that's how they did it. And they used some channels where they will do and put the wedge to make sure it is done. Pre-camber, everything should be taken care of. So this is where you do. After this, our last stage now is when you remove all this, and then the support system. You see, the stresses all goes now to the abutment, and you can see it is about 117 kilopascal. So your bearing capacity should be 200 and above. Remember that the deformation of this is about within 20 millimeters. So that is how we can do our construction stage modeling. So that is what we could do. And if you want to view the moments, you could actually have a look. You can see now. So this, if I go back to the soil, if I want to look at the pressure, this is what would happen if the holes. So this will be the soil pressure at the end of the construction stage. So if there's any deformation, now you can see the soil pressure here is actually 242. That's the bearing capacity we are seeing now here at the end of construction stage. So then if you want to look at other forces, you can still view other forces. This is the axial load happening on the truss system, transferring all this load onto the abutment, and down we go. So basically this is how we could do that. And what about you can see this is just self-weight moment happening on the members, but when you bring so this will be the kind of stress built up on the members, both the axial. You can see even these members are highly stressed. Partly this is self-weight, so this is how this loading will be building up. And then if I go and if I add another member, so you can see these forces so increasing, and the stress is distributed through the truss, the temporary support. Now the connectivity between the temporary support and this is using the temporary elastic links, which are the end of it all, they are all deactivated. So now then we do our this is how your axial load will be happening when you are doing your construction stage assembling of your steel truss system. Yep. So this is how I've managed to use my Civil and guide me. So that means when construction stage simulation is very important. Now What also we needed to do is the construction loading need to be taken care of. Wind load need to be taken care of. Of course, if you have a temporary support system, normally it is it's not all that very scary because it is held. But once you remove it, then definitely you need to make sure that the stability is okay. So I can also quickly look at the camber. So what would be our camber here? I think, let me see, do we have a camber table? This is the camber table that can help us to so you find in the construction stage number 2 when you begin, number 3 when you start placing these are the deformation which is being experienced. You need to follow this, plotting it properly. So at the end of construction stage number 6, the deformation should be 0, so that now whatever deformation we have past that stage is more of the any additional load past the construction stage. That is something to do with now life load deflections and other deformation that come thereafter. So this is your construction stage number, the last construction stage. So basically that is a demonstration of construction stage. Like now here, I showed you when you begin putting, when you start assembling this. When you start assembling this, that is here. You are doing it bearing in mind that they follow a pre-camber. So by the time we put this member in place, you torque it properly. When now you check the deformation, this should be 0. That's what I was trying to talk about in the pre-camber. Okay, good. So the brilliant guys, the youngsters, the Alfred, please start modeling and come up with a good super. We can also try to look at steel arch bridge. You can do whatever you want. You can, but at least this is how you could do that. This is for this demonstration of how I would approach the construction. I prepare the platform, I construct, I make sure I have all the crane, the lifting equipment, the torquing system for assembling and making sure the precision as designed is adhered to. And you enjoy. This is courtesy of Maida Silva, Uganda version. Thank you so much.